Okay. Apparently. Okay, so this is the section on the addition formulas. Okay, and rather than spend a considerable amount of time actually deriving the first one, then deriving the other ones, I'm just going to cut to the chase and keep things as easy as possible. You don't need to do any of that on the quiz or test. You might have to use the formulas for an identity. But most importantly, for this entire unit, you're going to have a formula sheet available that just because there's a ton of formulas in this unit, that has the formulas all on it for you. Okay? Your job for a big portion of this unit is simply knowing which formulas to use, when, and how to do so. Okay? So that's what we're going to focus on today. All right? So there are six, is it six? One, two, yeah. There are six formulas that we're going to talk about today. So let's just get them down and we'll talk about how these work, okay? We have cosine of s minus t equal to cosine s times cosine t plus sine s sine t. The cosine of s plus t, okay? So the first one is a formula for when we have two angles that are being subtracted. The second is a formula that we can use when we have two angles that are being added together. It's actually pretty much the same formula, cosine s times cosine t, but now it's a minus instead of a plus sign in between. Okay, so those are the cosine addition formulas. Once you start writing these out and using them in the homework or in the practice packet, which we'll get to later, you actually might even remember these. These are kind of easy to remember. Cosine, cosine, sine, sine, minus is plus, and then same pattern here, but plus is minus in the formula. Okay? Sine of s, let's do sine of s minus t. That's going to be sine of the first angle times cosine of the second. And then for the sine formulas, this minus sign stays the same. So it'll be minus the cosine of the first angle, sine of the second.
So t and s represent angles?
Yes. Actually, that's a good question. No matter what we have inside of these cosine and sine and tangent functions, if we're using letters or Greek letters or anything, these represent angle measures. Okay? So at all times, you need to make sure that you follow that we have angle measures going on throughout. Okay, the sine of s plus t, again, same pattern, sine of the first, cosine of the second angle, keep the addition sign the same, cosine of the second, sine of the first angle. Okay, and then there's two more, and then we'll actually go ahead and start using some of these. We have tangent of s minus t and also tangent of s plus t. For the tangent of s minus t, it's tangent s minus tangent t, and that's all over 1 plus the tangent of s times the tangent of t. And then the second formula for the tangent is, again, very similar. Same pattern. Tangent of the first. Now we add with the tangent of the second. And then in the denominator, we also switch the sign, so it'll be 1 minus tangent s, tangent t. Okay? So these 6 formulas will be used throughout this first section. Okay? Several things you need to be able to do with them. One, let's say, for example, that I ask you to simplify the expression cosine alpha. Oh, yeah, absolutely. Sorry. Cosine alpha times cosine of alpha minus beta plus sine alpha sine of alpha minus beta. Okay, I'm actually going to slide this down so that we can still see all 6 formulas. Okay, so for something like this, this is an example of going this direction. Okay, so somewhere on the right-hand side of this formula table, you should see the pattern cosine, cosine plus sine, sine. Which formula would that be? Which one? The first one. Cosine, cosine, sine, sine, same pattern, right? We have 2 different angles here. One angle is alpha, and then the other angle is alpha minus beta. So what we can do is use the first formula and then write it as, so if we're going from this direction back that way, we could say that this equals the cosine of S, which in this case would just be the first angle, alpha, minus, here we just subtract the second angle, which in this case the second angle is this quantity here. You guys see how I'm doing that?
No.
Okay. Oh, you literally couldn't see how I was doing that. Okay. So all we're doing is going backwards, right? We identify that this is an addition formula where everything's already kind of been plugged in. And what we're doing is saying, well, I know that we can rewrite this as the cosine of an angle minus the second angle. And all we did is identify that this was like the S in the formula, and that this whole quantity was the T. You guys see what I'm talking about now? Okay. So then all we're doing is going backwards, plugging in the 2 angles. And actually it works out pretty nicely because we can simplify in here. Okay. If we subtract and distribute the negative, what do we get? Just cosine of beta. Okay. So one thing that you have to recognize is when the formula is already kind of written out in its long form, going back to short form and seeing if that helps. Okay. Any questions on that? Okay. We got time to do a couple here. Let's try this one. This is the most common use. Let's say I wanted to find the sine of 75 degrees. Okay, so 75 degrees is not one of the nice angles on the unit circle, right? But the idea is, if we're going to use these addition formulas, could we maybe split up 75 into, and what was this? This is a sine problem, right? So could we use one of these sine formulas? Actually, we could use either one, but where we have an angle that we know about plus another angle that we know about, or maybe an angle that we know about minus another angle that we know about, right? 45 and 30, do you guys understand that? 45, we know all about 45 degrees, we know all about 30, right?
How did you do subtraction?
Let's see. We could do 120, or what would it be? 75. 135 minus 60. I mean, it's a little roundabout because like you wouldn't think to do 135, but 135 is an angle we know about. It's just in the second quadrant. Does that make sense? But certainly the most simple, I think we can agree, is just take 30 degrees, add it with 45. So technically we haven't changed that we have a 75 degree angle. We're just splitting it up into 2 angles that we know everything about. Everybody good with that? Okay. So now we follow the pattern of the formula. The pattern is, let's see if I can pull it up here. We're adding, so here we would do sine of the first angle, cosine of the second, and then we subtract cosine of the first, sine of the second. So we just plug everything in. Oh, I'm sorry, I looked at the wrong one. Thank you. So we're using this one. Sine of s plus t becomes sine s cosine t, so sine 30 times cosine 45 plus, now we do cosine of 30 and then sine of 45. And now just a matter of using the unit circle.
Wouldn't it be sine 30 or sine 45?
Yeah. It is sine 45.
Did you just flip it?
Well, because it doesn't matter the order that you add them in, but you need to have the sine of each and the cosine of each.
Oh, because I did it.
You see what I'm saying?
Yeah.
Okay. So sine of 30 degrees. Everybody should know that. What's the y-coordinate at 30?
So that.
Oh, boy. Hasn't been that long, guys. 1/2. Cosine 45. Patrick, put your phone away. Not off to a good start, man. Cosine 45 is what? Root 2 over 2. Plus cosine 30. So now what's the x-coordinate at 30? Root 3 over 2. Very good. Sine 45 is root 2 over 2. And now we just simplify. So 1 times root 2 is root 2. 2 times 2, 4. We can do root 3 times root 2, which is root 6. 2 times 2, also 4. So you could either leave it this way, or since they all have the same denominator, you can combine them into one fraction. Either one of these answers is perfectly fine. Okay. You guys kind of see how to work with these? They're not horribly difficult. It's just kind of like there's a lot of stuff going on, so you have to be very careful when you're plugging everything in. Yes?
At the top of the formulas, it says the sign of the quantity s plus t.
Yep.
And then in the formula itself, it's sine s cosine t minus cosine s sine t. And in this example,
No, it's plus.
Oh, okay. Already.
Did you switch them on accident? Okay. It's no big deal. Karen, you're right in front of Nate. So now you're here. All we're missing is Stephen and Ricky. Okay. Okay. Any other questions on this one? Okay.
Well, we're going to have to memorize this formula.
I'll let you figure that out. Maybe if you weren't on your phone, you'd know the answer to that. All right, let's try this example. Let's say we know a little bit of information about some of the angles going on. Let's say the cosine of an angle theta is 2/5. And we know that theta is between 0 and 90 degrees. And we also know that the cosine of another angle phi is negative root 5 over 5. And let's say this angle is between 270 degrees and 360 degrees. And let's say we want to find or evaluate cosine of theta minus phi. So here's what we know in blue, and in orange is what we're trying to get to. Say that again?
For the angle thing, it's going to be up, right?
What's up?
The angle is less than. The line's going to go up and down, right?
Oh, this one. 2 5
Oh,
Yes, thank you. This specifically refers to that angle. Yes, that's phi, by the way. You're behind Abby. Okay. So, if we're trying to figure out cosine theta minus phi, okay, I'm going to be very specific and very slow about going through this problem because I've seen all kinds of weird things from students before when doing this kind of question. Okay? Is that Stephen? Hey, Stephen. You're right there behind Ida. Yep. All right, so first, write out the formula. Absolutely, under no circumstances should you try to skip steps and just try to shortcut everything. Okay? So if we're looking for cosine of theta minus phi, keep in mind that all we're doing is using the s minus t equation and just replacing first the s's with thetas and the t's with phi's. Does that make sense? So this would turn into cosine of theta times cosine of phi plus sine theta sine phi. So our first step is just to rewrite the equation using the correct angles. Not a big deal, right? Next step. Do we know any of these? So second, do we know any of these? Are you sure? What do we know? We know that cosine of theta is 2/5. I gave it to you, right? So this becomes 2 over 5. You guys see how I'm doing that? I'm literally replacing the entire cosine with 2/5. Under no circumstances are you going to rewrite this. Do not. So no. I've seen this before. People write it like cosine like this. Cosine 2/5, and then they start plugging stuff in, and they're like, what? Well, what would I do with that? You're right. You can't do anything with that. It doesn't make any sense. Okay? 2/5 does not represent an angle. You guys understand that, right? It represents a ratio of sides. So when you replace the entire cosine, make sure you actually do that. All right. Do we know cosine of phi? Negative root 5 over 5. See how I'm replacing the whole thing, right? And now, do we know sine theta?
No.
We do not. Could we find it? Well, if we know cosine theta is 2/5, why don't we draw a little reference triangle? So if cosine is 2/5, this adjacent side has to be 2, hypotenuse has to be 5. Make sense? What's the missing side here? The opposite going to be? Root 19?
No, root
I don't think that's right.
21.
Isn't, yeah.
Oh, my bad.
25 minus 4, yeah, 21. So root 21 is the opposite side. And let's go ahead and do the reference triangle for the other angle, because we're probably going to need it. Phi. Cosine was root 5 over 5. So Pythagorean theorem says we can do 25 minus 5, which is 20. So the root, when you reduce it, would be 2 root 5. Okay, sorry, I'm kind of skipping that. If you have to write it out, it's no big deal. All right, so now let's take a look and see if we can figure everything out. Bless you. So now, again, I've said this a few times. I never use negatives with the triangles. This is just a reference for me to figure out what ratios to use, and then I put in the negatives in the problem depending on where the angle is. Okay? So let's look at sine theta. Sine theta would be opposite over hypotenuse, so root 21 over 5. And now let's check where is theta. Theta is first quadrant, so do we need to do anything there? Nope, so that's good. Sine of phi, we do opposite over hypotenuse again. 2 root 5 over 5. And let's see, where is phi? So quadrant 4. So this one was in quadrant 1. This one was in quadrant 4. Sign is negative down there. So I'm going to put a negative sign for this sign ratio. Is everybody good with that? And then we clean everything up as much as possible. So let's see. We have negative 2 root 5 over 25. That's from the first fraction. Plus root 21 times 5. Negative, so it'll be negative 2 root 105 over 25. And I don't think the root 105 is going to reduce at all, because that's just 3 times 7 times 5, so that's good. So you could either leave it this way or put everything into one fraction, and there's your answer. Okay, everybody good with that? All right, one last problem. One last problem. I'll let you guys try this one on your own, okay? Let's try to figure out the tangent of 5 pi over 12. See if you can figure out how to do that. I'll give you a couple minutes to try it. I think we all know 5 pi over 12 is not on the unit circle, so you're going to have to try to split it up somehow. Okay, so see if you can figure it out. I should clarify. Of course 5 pi over 12 is on the unit circle. It's just not one of the nice angles, right, that we know about. Everything's on the unit circle. We just don't know the coordinates for that.
You know, 4 pi over 12 is great. Pi over 3, but pi over 12 we don't know. You're on the right track.
Think about splitting up the 5 pi into something pi over 12 plus something pi over 12. That would end up reducing to some nice angles. So rewrite this as like tangent of angle 1 plus angle 2. Does that make sense? And then you're just going to plug everything into that.